Now, to put it all together, you need to talk about Gibbs because this is putting it all together. You take the entropy, which has a tendency to be negative. You get an entropy that tends to be negative, entropy that tends to be positive, and increasing temperature as well helps with the entropy. And so overall, that all leads to a negative number. So basically, Gibbs for energy is it going to happen? So if the delta G is negative, it's spontaneous. Delta G is positive, it's not spontaneous. So you compare these two values to work out whether there is going to be a reaction is going to occur or not. So that's just a summary here. And so we'll go to an actual equation. So why there shouldn't really be any sort of reaction that gets colder. Any reactions that get colder is against the enthalpy heat of the spread of heat. So it's actually absorbing heat and the chemical strong bonds are getting stronger. So whenever you see an endothermic reaction, have a careful look at what's going on. This is three particles turning into 13 particles. No gas is formed. They're all liquid. Well, that's a solid going to a liquid as well. These are two solids that you mix together, by the way. And that becomes a liquid. That's liquid. So you're getting a massive increase in particles and change in state. The numbers are here for the reaction. So if you do the calculations here, it comes up to quite a negative number, um, huge negative number, and that actually freezes and sticks a piece of wood to it with the wool that was condensated on the outside. And so that explains to you why reactions that are endothermic do occur. And so the thing that always gets me in this is that biology always violates these two rules and does the opposite. It actually creates energetic molecules like glucose and it creates more order as well. And it's the glucose is storing more energy in the bond, so it's concentrating the energy. And so this is what I think is a good place to enter a religion or supernatural force to it, that life has some sort of supernatural explanation to it. And most religious texts do relate to that. This one here is from the Christian perspective, or actually the books of the Torah, so that could be Jewish or Muslim or a Christian viewpoint, because it's a very early book that they all base it on. And so that's saying that a living being, is not a living being until there is some supernatural element that's applied to it. And that is why it violates the laws of science. Okay? So that's a possible explanation. You may have another explanation. And so this is what we're going on here. So if it agrees, like the delta H is negative, which is what we want, and the delta is positive, it's always going to be spontaneous. Um, and if it's the opposite, which is what we never want, which is positive, which is endothermic and ordered, it's never going to work, although life violates that. It's these ones here where one is favorable and the other one's not. You have to do the mathematical equation to work out whether it works or not and see what temperature it's working at, um, just for you to appreciate. And so there's a mathematical calculation that you can do to work out whether a reaction will occur or not using those values that we saw on the previous video. There's a table of them. Okay, and just to touch on Year 12, Unit 3, I often explain enthalpy as, sorry, equilibrium as, and that's an equilibrium there, symbol there. Um, so that normally is, how well they can hold on to for a week out of a week base. It's just they hold on to the hydrogens or the OHs quite well, so they don't completely break off. And there's a certain amount here and a certain amount here at equilibrium. This is another factor that's not that don't take into account because entropy is not taught. But you can see here that it is exothermic, so you would think this is favoured, and so the reactants not turning into products is a penalty. It's violating the laws of enthalpy. But you can see you're going from 4 particles of gas to just 2, and so the favouring is actually on this side as well, and so that's an entropy penalty over there. So you can see one side wants to go this way because of enthalpy, and the other one wants to go the other way because of entropy. And so they balance out. So there's a certain percentage here and a certain percentage here. I usually just explain it with pos and neg, and that they're closely related into how much the positive and eggs are attracted on either side, and that does work at least for weak acids and weak bases. But this is a another good way to look at it, especially for the Haber equation. Okay, so I hope that's helpful, and give a like if you liked it. Thank you.